3, 2, 1. Engines at maximum thrust and we have liftoff. Launching into space comes with a hefty price tag. That's probably not news to you. However, what I can reveal is that behind every rocket launch lies an intricate process concealed from view. It's an expedition that the majority of people have never truly contemplated. This journey spans the entire breadth of America, from one coast to the other. It requires the expertise of hundreds of extraordinarily talented professionals, dedicating thousands of work hours across weeks and months of meticulous preparation. It calls for the most advanced levels of scientific breakthrough and technical prowess. And no rocket exemplifies this better than the SpaceX Falcon 9, a launch vehicle that takes flight every 48 hours, transporting hundreds of tons of cargo and crew members into Earth's orbit annually. Reaching space has never been more accessible than it is aboard the Falcon 9. Yet that convenience hasn't translated into affordability. So where exactly does all that capital end up? Well, the initial and most costly phase of reaching space is, naturally, constructing our launch vehicle. An orbital rocket consists of three primary elements. These are the booster, the upper stage, and the payload fairings. The booster stands as the largest and most financially demanding of these three components, representing approximately 60 to 70% of the rocket's entire production cost. In the context of the SpaceX Falcon 9, we have two potential paths forward. The expensive route involves manufacturing a brand new booster from the ground up. The economical alternative is refurbishing a previously flown booster that has already completed a space mission. And we're going to explore how this refurbishment strategy serves as the cornerstone of SpaceX's economic model. However, let's begin by examining the expensive route. A Falcon 9 booster derives its thrust from 9 Merlin 1D rocket engines. Each of these engines carries a price tag of approximately $1 million. The Falcon's structural body is constructed from a specialized metal compound combining aluminum with lithium. Then there's the landing apparatus. 4 deployable legs fabricated from carbon fiber materials, each costing between $50,000 and $100,000. Working in tandem with 4 aerodynamic grid fins manufactured from cast titanium at a combined cost of $200,000 to $300,000. There's even white exterior paint, which may seem insignificant, but considering a product of this magnitude, that represents a substantial quantity of paint. All factors considered, producing a new booster will cost somewhere between $30 and $40 million. Next, we move to the second stage. This segment of the rocket is disposable, requiring a completely new unit to be constructed for each mission. An upper stage involves considerably fewer components. It contains just a single Merlin engine, a comparatively compact lithium-aluminum body, and a payload mounting adapter. SpaceX maintains minimal production expenses by leveraging economies of scale. The company manufactured more than 140 upper stages throughout 2024 at a unit cost of $10 to $12 million per launch. Then we have the payload fairings, clamshell-shaped protective panels forming the rocket's nose cone that shield the cargo during atmospheric ascent. These appear straightforward, but their construction demands considerable effort. The external surface consists of premium aerospace-grade carbon fiber sheets, delivering structural rigidity and tensile strength. These sheets are supported by an aluminum honeycomb framework that preserves the fairing's geometry and stiffness while keeping weight to a minimum. Between these layers sits a cork barrier providing thermal insulation and impact resistance. The fairings are engineered for durability because they're designed to be reusable, just like the booster section. Following the fairing separation and atmospheric re-entry, they make an ocean landing where SpaceX retrieves them using a dedicated recovery vessel. That may sound labor-intensive, but considering the roughly $6 million cost of producing a new set, the recovery operation proves economically justified. This brings our complete, newly manufactured Falcon 9 to a total construction cost of approximately $50 to $60 million. This is where the situation becomes particularly intriguing. All of this rocket hardware originates from SpaceX's manufacturing facility in Hawthorne, California. Hawthorne is located in the Los Angeles suburban area. Meanwhile, most rocket departures occur at Cape Canaveral in Florida. That facility sits at the completely opposite end of the nation. So what's their transportation method? One of the fundamental design requirements for the Falcon 9 was ensuring it remained compact enough for overland transportation. Larger rockets encounter significant transportation obstacles. They require barge transport, sometimes navigating all the way through the Panama Canal and back again. Alternatively, they must be loaded into highly specialized cargo aircraft. SpaceX prioritizes cost reduction, so they transport their rockets via truck convoy. The Falcon 9 travels in separate segments. The first stage booster measures approximately 140 feet in length with its landing legs in the folded configuration. The second stage is more compact, measuring around 40 feet. The payload-faring ship is two separate halves, each measuring roughly 43 feet long and 17 feet wide when secured for transport. The components receive protective wrapping and are secured onto custom-designed trailers to safeguard them from weather exposure and road debris. Departing from Hawthorne, the Falcon 9 convoy travels eastward through California, then Arizona, New Mexico, Texas, before heading south into Florida, a journey covering approximately 2,700 miles if they encounter no route diversions. The trip requires between 4 and 7 days depending on rest stops, permit requirements, and weather conditions. Travel speeds are restricted to a maximum of 50 miles per hour due to the cargo's dimensions and mass. The booster alone weighs approximately 50 tons when empty of propellant. Coordinating a convoy of this nature is no minor undertaking. You can't simply cruise across the country with a rocket secured to your trailer. Oversized cargo requires state-specific permits, escort vehicles, and occasionally temporary roadway closures. Naturally, none of this comes without significant expense. When factoring in the cost of the transport trucks, diesel fuel, workforce wages, permit fees, toll charges, specialized equipment, and insurance coverage, the expense of transporting a complete rocket totals around $150,000. Still, within the context of rocket production, transportation represents a relatively minor expenditure. The 7-day transcontinental journey costs only about 1/10 the price of a single Merlin engine, which explains why SpaceX chooses to recover and refly their boosters as frequently as possible. This approach still isn't inexpensive, but it proves substantially less costly. Here's what that process entails. The most frequent landing scenario for a Falcon 9 involves touchdown at sea on the platform of an autonomous drone ship. SpaceX operates 3 of these vessels and has been utilizing them since the very first booster landing experiments. Consequently, they've already recovered their investment many times over. On the ship's deck sits a robot designated the Octograbber. It will secure the booster during the voyage back to port. Upon arrival at Cape Canaveral, a SpaceX crane offloads the booster from the vessel onto a truck, which transports the rocket a brief distance to a SpaceX facility designated Hangar AO on Roberts Road at the Cape. The expense of returning the booster from sea typically ranges between $10,000 and $20,000, depending on meteorological conditions, which might seem negligible at this stage, but all we've actually accomplished is retrieving the rocket from the water for the price of a pre-owned Honda Civic. Within the hangar, the booster undergoes an initial visual examination by technicians searching for damage and deterioration to the thermal protection system. The booster's base features an ablative layer of heat-resistant material. Ablative signifies that it's engineered to erode as it experiences heating. Therefore, any sections showing erosion on the thermal shield require patching. The 9 Merlin 1D engines undergo inspection for carbon deposits, turbine blade fractures, or injector component wear. There's also a comprehensive data analysis following every flight. Onboard monitoring systems record stress levels, temperature readings, and vibration data, compiling them into a diagnostic assessment. If the engines show any concerning indicators, they're removed and partially disassembled. SpaceX employs borescope cameras to examine the engine internals without performing a complete teardown. It's essentially an endoscopy for the rocket. Similar to an automobile engine, the Merlin requires regular maintenance intervals. It's standard procedure to replace sealing components, gaskets, and turbine blades between missions. However, in cases of substantial damage, an entire engine may require replacement. The propellant tanks undergo depressurization, draining of any remaining fuel, followed by cleaning to eliminate any contaminants. Landing legs are examined for structural cracks or hydraulic system problems. Grid fins are inspected for impact damage or thermal deformation. Meanwhile, the rocket's exterior receives a pressure washing to remove loose carbon deposits and char from atmospheric re-entry. Then they reassemble everything. Following the reattachment of the legs, grid fins, and engines, the booster returns to the launch complex for a static fire test to verify that all systems are functioning as intended. Because SpaceX maintains so many boosters in their operational fleet, it's probable that the booster will be stored in Hangar AO for a period until assignment to a new mission. This turnaround period can be as brief as 27 days, but the standard process requires between 1 and 3 months before a booster returns to active service. The precise cost of booster refurbishment is difficult to determine definitively, and it genuinely depends on the extent of work needed for each individual unit. However, industry experts have estimated the cost at approximately $250,000 on the lower end to as high as $2 million on the upper end. Compare that figure once more with the $30 to $40 million required to manufacture a new booster from scratch. The economic benefit of a reusable rocket becomes remarkably evident. Now that we have all of our rocket components ready for launch, it's time to combine the 2 stages and the payload into one unified vehicle. SpaceX utilizes a horizontal integration facility situated at their launch site, meaning the entire rocket is assembled while positioned on its side. The first stage rolls into the HIF and is positioned on a support structure. The technicians then establish electrical and fluid connections. The second stage is lifted by crane and aligned with the booster's interstage. That's a black carbon fiber structure that enables stage separation during flight. The 2 sections are bolted together and connected through umbilical interfaces for power and data transmission. The payload connects to a mounting adapter and gets enclosed within the rocket fairing. This occurs in a cleanroom environment to prevent contamination. The encapsulated payload transfers to the integration location, often on a specialized transport trailer under controlled environmental conditions. The payload is then hoisted and mounted to the top of the second stage. The final operation inside the facility involves integrating avionics systems like flight computers and sensor arrays, then testing them to verify communication between stages and payload. With all systems validated, the fully assembled Falcon 9 is loaded horizontally onto a mobile platform, and it's transported a short distance to the launch complex just over 1 mile away. Once the Falcon 9 reaches the pad, the mobile platform employs its hydraulic system to raise the rocket to a vertical orientation, aligning it with a support structure called the strongback. Once erected, securing clamps hold the rocket and umbilical connections link to the launch tower for propellant, electrical power, and data transmission. This entire process of integrating the rocket and positioning it at the launch complex requires between 1 and 3 weeks depending on the payload's complexity. Straightforward Starlink payloads would be closer to 1 week, while a NASA mission carrying the Crew Dragon will require closer to 1 month of preparation. Given that SpaceX can launch at least one Falcon 9 every 3 days, it demonstrates that their integration procedures are highly refined with multiple rockets being prepared simultaneously. Therefore, by calculating the cost of wages for a team of between 50 and 100 technicians, engineers and support personnel, facility lease payments to NASA for the use of their hangar and cleanroom, equipment expenses for the cranes and transport vehicles, plus all of the single-use hardware required for securing the payload, we'd be examining an average expense right around $1 million to assemble a rocket and position it on the launch complex. Now it's time for the rocket propellant. Falcon 9 operates on 2 types of fuel. RP-1, which is rocket-grade kerosene, and liquid oxygen, which is simply oxygen that's been cooled to extremely low temperatures until it's dense enough to propel a rocket into space. The Falcon 9 booster requires approximately 410 metric tons of propellant. The mixture ratio is about 75% oxygen to 25% kerosene. The upper stage needs approximately 95 metric tons of propellant with the same 75 to 25 ratio. So that's just over 500 metric tons of propellant for one single rocket launch, which equals the mass of 10 blue whales. So where does it all originate? Well, RP-1 is a highly refined fossil fuel derived from petroleum crude, just like gasoline, and it's manufactured by the same suppliers you might encounter at your neighborhood gas station like Chevron or ExxonMobil. The cost of RP-1 is also fairly comparable to gasoline, approximately $1.50 per liter. There are only a handful of refineries that produce RP-1 though, and the nearest to Cape Canaveral would be located in Houston, Texas. RP-1 is transported in stainless steel tanks towed by semi-trucks. You need 5 truck deliveries to fuel one rocket, and that convoy travels approximately 1,000 miles to reach the launch facility. Meanwhile, liquid oxygen is generated by air separation plants, which cool atmospheric air to negative 195 degrees Celsius. That makes it considerably cheaper compared to RP-1 at only about 25 cents per liter. Given that liquid oxygen has been utilized in every rocket launch since the 1960s, there are established ASU facilities right near Cape Canaveral. The liquid oxygen is shipped in vacuum-insulated cryogenic transport tanks, and SpaceX requires about 15 truck deliveries per launch. That establishes the total cost of delivering propellant for one rocket at about $350,000. And there's another critical liquid involved in launching a rocket: water. Hundreds of thousands of gallons are released into the area directly beneath the rocket engines in the moments preceding ignition. The water deluge system functions to absorb thermal energy from the rocket exhaust, but it also performs an essential function of suppressing the acoustic energy from the engines, which can generate vibrations so intense that they would compromise the rocket, the payload, and any adjacent structures. The launch complex is surrounded by water, but that's not what the deluge system utilizes. Each launch facility has its own massive water storage tower. Falcon 9's tower stands 300 feet tall. It was initially constructed for the Apollo lunar missions back in the mid-1960s and stores up to 400,000 gallons. The source of that water originates from the city of Cape Canaveral. Municipal water is extracted from the Florida aquifer, an enormous underground reservoir. So, in comparison to everything else associated with a rocket launch, the water deluge might appear extreme, but it's actually affordable and straightforward. Even when you calculate the electricity to operate the massive pumps and the cost of maintaining the plumbing infrastructure, it's just about $1,000 per launch. So, with that, we can begin calculating our total expense to launch one Falcon 9 rocket into space. There's the rocket itself. That's invariably going to be the most substantial expense. And assuming we've utilized a refurbished booster, the average cost of the Falcon 9 is going to be $21.5 million from top to bottom. The expense of transporting the hardware from California to Florida is about $150,000. The integration process costs $1 million. The fuel expenditure is $350,000. Water and electricity bills total $4,500. Then we must also calculate the administrative expense of securing launch licenses and filing environmental reports. That would average around $250,000 per launch. There's also a personnel cost for every employee at SpaceX associated with the launch. Process in any capacity from ground controllers to live stream, operators and maintenance staff. Around $2 million on average per launch there. Maintenance of the concrete launch complex itself amounts to around $125,000 per launch. And then there are corporate overhead expenses on all of the equipment and facilities, plus research and development investments that enable an operation like Falcon 9, about $3.5 million per launch. So when we calculate that total, we arrive at a total average cost per Falcon 9 launch, and that comes to right around $28.9 million. And that figure just so happens to align remarkably closely with what SpaceX Director of Vehicle Integration Christopher Koulouris told reporters in the year 2020. He stated that Falcon 9 costs $28 million to launch. That's with everything included. In the 5 years since that statement, there's been substantial inflation, but SpaceX has also dramatically increased their launch cadence. In 2020, Falcon 9 flew 26 times. By 2024, the company achieved 132 launches in a year. So, economies of scale can be tremendously effective at offsetting price inflation, which leads us to another significant point. We've determined what it costs SpaceX to reach space. So, when you observe one of their Starlink missions, now you understand the expense they incurred. But how much does a SpaceX customer pay to place a payload into space? And how much profit does SpaceX generate? For one dedicated Falcon 9 launch with a maximum payload capacity of 22 metric tons, you are going to be paying between $70 and $75 million, providing SpaceX with an approximately 60% profit margin and placing somewhere in the range of $40 million in their accounts. Now, there is a more economical method to get your cargo into space as long as it's relatively compact. SpaceX rideshare missions on Falcon 9 deployed dozens of small payloads from multiple clients. To secure a spot on this flight, you'd be paying $6,500 per kilogram of payload. If SpaceX maximizes Falcon 9's capacity on one of these rideshare missions, they can generate as much as $80 million in one launch, representing about a 74% profit margin. And the most expensive journey to space is when you transport human beings. A Crew Dragon mission carrying astronauts on board is going to cost NASA up to $150 million, which sounds like substantial money, but this figure actually demonstrates just how economical Falcon 9 truly is. When NASA launched their astronauts on the space shuttle, that would cost them $1.5 billion per launch. When the shuttle program was terminated and NASA transitioned to purchasing seats in the Russian Soyuz capsule, that would cost them $86 million per seat. So transporting 2 astronauts to the ISS was $172 million and required complete dependence on a foreign nation. The SpaceX Falcon 9 has made space accessible in a manner that was previously thought to be unattainable. By relentlessly pursuing reusability with their rocket booster, SpaceX managed to dismantle the most formidable obstacle: cost. That still doesn't mean that reaching space is inexpensive, but the expense is trending in the favorable direction. And with their next major rocket venture, the Starship, SpaceX has a new opportunity to revolutionize the industry all over again.